So in this video, we will try to understand, can a lambda access a variable that is defined outside the scope of lambda? If yes, when can we do it? If no, then what are the possible reasons? So here we have a lambda that is basically an implementation of the calculator functional interface. Then we are calling the calculate ops method. Same old story. Now, in the main method, let's say we have an integer variable counter that is initialized to 0. Now, can we use this counter variable within this lambda? So let's try to do that. So if we simply print the counter within this lambda, we see that's allowed. We don't see any compile time error. So we know that, okay, if there is a variable declared outside the scope of lambda, then we can use it in the lambda. That's fine. But what's not allowed is that we cannot change the value of this variable. So if we think to do something like this, let's say counter +1, and then try to print the updated value of the counter, then we see there are a lot of compile time errors. And if we go mouse over, then it says that variable used in lambda expression should be final or effectively final. So that means we can access a variable defined outside the scope only if we are not changing the value of that variable. If that value is getting changed within the body of the lambda, then it's not allowed. We cannot change the value within the body of the lambda. So let's revert that and let's see if the value is getting changed outside of the body of lambda. So we see the main method is basically incrementing the counter, but now can we access the same variable? Again, we see the same problem because the Java compiler knows that although we are not changing the value within the lambda, but the value of this variable is getting changed. And this is not a final variable, and this is not effectively final. Its value is getting changed, so this is not allowed. We cannot use a variable whose value is getting changed either within the lambda or outside the lambda. So we cannot use certain variables in the lambda. Let's revert that. Now, the compiler warning says that it's not final and it's not effectively final. What does it mean? So we know that if the value of a variable is changing, then we cannot use that variable in lambda. What we can do is we can only use final variables. Final variable means that if we declare a variable final, then it means the value of that variable cannot be changed once initialized. So in this case, if we initialize the variable with 0 value, then it means this is fixed for its lifetime. We cannot change the value. And now we can safely use this variable in the lambda. Because compiler knows this is a final variable and the value cannot be changed. So it can be sure that, okay, the value in the lambda will always be 0 or the value that was initialized. Now, if we remove the keyword final, then there is a way, it is possible that the value will be changed if someone is doing any operation on the counter variable. Now, what is effectively final? Effectively final variable is a variable that is not declared final explicitly, but the value of that variable is not changing anywhere. So in this case, in the main method, we have not declared the counter variable final, but the value remains 0. Nobody is changing the value of counter anywhere in the main method. So this variable is effectively final. So the guideline is, in order to use a variable in lambda, the variable either must be final or effectively final. So the bottom line is the value cannot be changed. All right. So we can use a variable in Lambda only if it is either final or effectively final. Now think about it. Why is it not allowed? So we know that in Java, all the local variables, they live on the stack. Whenever we declare or define a new variable in the method, that variable goes onto the stack, the method stack. But if we are saying that the local variables, the the local variables actually whose value is changing, that can be passed to lambda, then we need to understand that a lambda can outlive the scope of the method, and that means the local variable will outlive the scope of the method, which is something new and which doesn't follow the actual design of Java, and it could have caused a lot of problems. So they did not allow a non-final variable to be used in Lambda. Second thing is, we know that each program runs at least in a thread, which is the main thread, and lambdas can be passed down from one thread to another. So if this is allowed, that means that local variables, they are not thread safe anymore. So we know that whatever variable we define or declare within the body of the method, they are thread safe because they are not visible to another thread. But if that variable is used in Lambda and the value of the variable can be changed, then it means that if we are passing that Lambda function or that Lambda expression to another thread, the same local variable can now be mutated by more than one threads. So local threads that used to be local to the thread, not visible to other threads, they are now open. Any thread can access them depending on the implementation, and they can mutate the local variables, which will cause a lot of concurrency related problems. And to solve them, we'll have to use some type of synchronization or another visibility fixes, for example, volatile, that will essentially increase the contention and it may decrease the performance. That defeats the whole purpose of Lambda. So I believe those are the reasons that the local variables are not allowed in Lambda, especially if the value is changing. We can only use final and effectively final variables because we know that the value is not going to change. So we can safely use them in Lambda. We can safely move the Lambda from one place to another place because we know that the invariant remains the same, precondition and postcondition of local variables, they remain the same. All right, so we need to remember this thing. If we want to use a variable in the Lambda, then we need to make sure it's either final or effectively final. That's it for now. Thank you.